This is the analysis of the pitching biomechanics of Danny Collinson. Danny threw fastballs, curveballs, and cutters from the stretch during his evaluation. His fastball velocity and joint forces and torques will be compared to elite high school pitchers, while his joint motions or kinematics will be compared to elite adult pitchers' fastballs previously tested at ASMI. This evaluation provides recommendations based on previous research at ASMI of proper pitching mechanics. However, these changes should be made under the supervision of a certified pitching coach. If any arm problems present themselves after making the recommended changes, please consult your pitching coach, medical staff, or ASMI prior to continual pitching to prevent injury. The tables on each of the following slides will show the variable of interest, as seen here on the left. The range for elite high school pitchers' fastballs, seen here in the middle, and Danny's data, as seen on the right. During this evaluation, Danny threw an average of 76 miles per hour for his fastball. As an introduction to the data tables as seen below, if the value of Danny's data is white, he's within the range of elite pitchers. However, if the value is red, he is outside this range. Our first discussion point in this evaluation is Danny's lead foot mechanics at the instant of foot contact. There are three aspects of pitching mechanics that are required to establish a proper rotational base of support. The first of these is a pitcher's stride length. Stride length is measured from the rubber to the lead ankle as seen by this red line and is reported as a percentage of the pitcher's height. It can be seen that Danny has a proper stride length with 78% of his height. The second is the position of the lead foot when it contacts the ground. If we were to draw a target line from Danny's back ankle towards home plate as seen here, most right-handed pitchers step approximately 4 to 14 inches towards the third base side of this line. It can be seen that Danny has landed 1 inch towards the third base line, which is below the elite range. In order for Danny to improve his rotational base of support, along with correcting other measures up his body, it is recommended that he land with his lead foot more close to the target or towards the third base side. However, along with foot placement, lead foot angle is also important in establishing a balanced rotational base of support. Again, we draw a target line, this time from the heel of the lead foot, and we see that elite right-handed pitchers angle their foot -2 to 20 degrees towards the third base line. It can be seen that Danny is landing with his lead foot angled 10 degrees towards the third base line, which is in the proper position. Now, after discussing Danny's lead foot mechanics, we will see how this affects his lead knee. Knee flexion and the amount of bend in Danny's knee can be seen as a smaller angle created between these two red lines. Knee flexion is important for storing energy in the muscles of the legs and transferring that energy up the kinetic chain. At the time of foot contact, we can see that Danny has landed with his knee bent just above the elite range with 54 degrees. However, now when looking at the time of ball release, we can see that Danny has maintained roughly the same amount of knee flexion with 53 degrees. In order to pass more energy up his body into the baseball, it is recommended that he work on extending his lead knee through the point of ball release, which may be easier to do once he has corrected his lead foot position. Continuing up the body, we will now look at how Danny's lead knee affected his kinetic chain. The kinetic chain is a transfer of energy from the ground up the body to produce ball velocity through a sequential rotation of the body's segments. In a pitcher, this starts in the image on the left. At the time of front foot contact, they absorb energy in their lead leg and transfer that energy up to their pelvis or hips. An elite pitcher will then rotate their pelvis, reaching a maximum velocity reported in the table in degrees per second, creating stretch in their core muscles between their hips and trunk. They then fire their shoulders, referred to here as upper trunk rotational velocity, cocking the arm back and transferring energy to their throwing arm, as seen in the image in the middle. The pitcher then simultaneously internally rotates at the shoulder and extends at the elbow to transfer this energy to the baseball. An efficient kinetic chain requires that the timing in which these rotations occur is in sequence, so this table also shows the time of maximum pelvis and maximum upper trunk rotational velocity, with time reported as a percentage of the throw. Here, 0% represents time of front foot contact, and 100% represents time of ball release. Overall, when looking at Danny's transfer of energy using the kinetic chain, it can be seen that his maximum pelvis rotation velocity is below the elite range. And in order to increase this, it is recommended that he work to correct his lead foot position, which will allow his knee to extend, forcing his hips to rotate at a higher velocity. The last item we will discuss is Danny's forward trunk tilt at the instant of ball release. Forward trunk tilt, or how much Danny has tilted his trunk towards the target, can be seen as this angle created here. When looking at the table below, we can see that Danny is below the elite range for his forward trunk tilt with 27 degrees. Again, this is tied back to his lead foot and knee, and if he were able to correct these measures, this would force his hips back while his trunk would continue to tilt further forward. In summary, the first item that was discussed in this evaluation was Danny's lead foot position at the instant of foot contact. It was noted that Danny landed with his lead foot too open or towards his midline. In order to provide him with a proper base of support and assist with other measures up his body, it is recommended that Danny work to land a few more inches towards a closed or throwing side. Continuing up the body, the next item that was discussed was Danny's lead knee. It was determined that he maintained roughly the same amount of knee flexion throughout the entire pitching motion. In order to transfer more energy up his body into the baseball, it is recommended that he work on actively extending his knee through the point of ball release, which may be easier to do once he has corrected his lead foot position. The next variable that was mentioned was Danny's transfer of energy using the kinetic chain. It was noted that his maximum pelvis rotation velocity was below the elite range, and in order to improve this measure, it is recommended that he work to actively extend his knee to force his hips to rotate faster. The last item that was discussed was Danny's forward trunk tilt at the instant of ball release. It was determined that he was below the elite range for his forward trunk tilt, which again ties back to his lead knee not extending due to his lead foot. Overall, Danny has some good aspects to his pitching mechanics. However, there are a few changes he can make to reduce his risk of injury while also improving his performance. After Danny has had time to implement these changes into his mechanics, it is recommended he come back to ASMI for a follow-up assessment. A complete list of all of Danny's data can be found in the Biomechanical datasheet. If you have any questions, feel free to contact us at 205-918-2119.